negative x plus 5, a y-intercept of 5, and a slope of negative 1, which is down 1, right 1, down 1, right 1. We're just going through the diagonals of every square. And then we want to evaluate this guy from negative 1, which is right here, to 1. So this is our shaded region. To evaluate the area of this shape, we have to think about what shape this is. It is a quadrilateral, and 2 of the sides are parallel to each other. This side and this side are parallel to each other. Remember that this is called a trapezoid. So I want you to go find the area formula for a trapezoid. The area formula for a trapezoid is 1/2 times height times base 1 plus base 2. And we know that these formulas are a little misleading because height doesn't actually really mean height. Height is the distance between the bases, and base doesn't really mean like what it's lying on. It is implying a certain type of relationship. And in this case, the base 1 and base 2 are the two segments, the two sides that are parallel to each other. So if we were to kind of pick and choose what we wanted to plug in first, base 1 and base 2 are the ones that are parallel to each other. So it's actually this side length and this side length. So that's 4 is this base, and this base is 6. And then the height is the distance between those two bases, which is 2. This ends up getting us 10. So then evaluating the integral, practicing writing the integral as well, the definite integral. We're finding the integral between negative 1 and 1 of negative x plus 5 dx. Go ahead and find the general integral for this guy. This x becomes x squared. So I'm going to write that out, x squared. And then I know I would divide by that 2. So that would be negative 1 divided by 2. So that's negative 1/2 plus, and then 5 becomes 5x. And then I'm going to evaluate that from negative 1 to 1. I'm going to plug in 1 first. And then I'm going to subtract plugging in negative 1. So then this becomes negative 1/2 plus 5 minus, and then this becomes negative 1/2, and then that becomes minus 5. Distributing that negative to both pieces, we get negative 1/2 plus 5 plus 1/2 plus 5. So that negative 1/2 and positive 1/2 cancel out, and we're left with just 10, which we knew is what was supposed to happen, but it's kind of cool to see the mathematics all come out together and see how it could come down to something like 10. All right, last one. This one is going to be a little bit different because we don't know how to graph this guy. We haven't really talked about it. And we don't know how to find the integral of this guy. So we're going to use our calculator for all of this. I first know that I'm only going to have my boundaries of the x-axis below, and I'm going to be between the interval of negative 2 and 2, which means that I need to have my x-axis where I put it and my y-axis where I put it. Then I grab my calculator, go to my graph, and we'll see what this looks like. So this is half of a circle, which is kind of cool. Your equation of a circle is when you have both y and x squared, but the equation of a circle is not a function. And so when you have it as f of x equals, and it's only the positive version of this, it just takes the top half of the circle as opposed to both the top and the bottom half of the circle so that it is a function. Kind of. It is a function. Equations aren't sentient enough to like make that decision, but that's how it works, is what I mean by the kind of. So it's a semicircle. So we go ahead and draw in that semicircle and we can shade it in. And then we want to find that area. Okay, so area of a semicircle is 1/2 times the area of a circle. So plugging in, our radius here is what? What is the radius of this circle? The radius of this circle is 2. We start here at the center, and this is our radius. You can see that it's equal across all corners. 1/2 times pi times 2 squared is 2 pi, which is about 6.28. Now, finding the integral between -2 and 2 of the square root of 4 minus x squared dx, we don't know how to find the equation of the integral for this guy because we haven't learned it. There is a way for sure that we could calculate this chain rule, but we don't know the chain rule, so we're going to use our calculator. So we go to menu, we go to probability, and we go to numerical integral. And we're going to go from -2 to 2 of the square root of 4 minus x squared dx. Remember that this should only be used if we don't know how to find the integral of a situation, right? If we don't know how to find that integral, but we're trying to look for a definite integral for a measurement, your calculator can find it for you. But remember that on the test, you might be asked like, hey, find the integral, use the integral to find the definite bounds or whatever. And so if you don't know how to do this by hand as well, you just won't get your points. So just be aware. And this is approximately 6.28, which we anticipated. Now moving on to the actual point of this unit is being able to now take this information, this idea of knowing that your integral is the area bounded beneath your curve and the x-axis. So when we have that in our knowledge box, in our brain, then we can use it in an appropriate way. So it says the graph of this function is provided. Find the area enclosed by this graph and the x-axis. So if we wanted to find the area, we're only given this equation, and we want to know the area just bounded by that and the x-axis. So first I'm going to try and understand this visually. So even if it's something just small, like shading, that area, it's kind of a nice just like grounding in the problem of that panic of where do I even begin? This is a great place to begin. And now that you've shaded it, you can kind of say like, okay, when I'm finding the area beneath a curve, what I've been doing so far, what are some things that I've needed? I've needed the equation, which is good. I have that, and I know how to find the integral of that equation. But I've also always had bounds, and I don't have bounds for this situation. So I have to kind of look at this diagram and see like, well, what would be my bounds in this situation? Even if you don't know the number, can you like pinpoint with your pencil where the bounds would be in this situation, right? So taking a second to be like, what do I normally have that I don't have now, to be able to name it and say, well, then how do I get that? That's a huge part of your problem solving process. Hopefully by now you'll be able to notice that, well, we start here and end here, right? We start at this point right here and end at this point right here. Well, those 2 points are what we call your x-intercepts, which we can totally find for this equation. Remember that your calculator also finds x-intercepts for you. If you go to algebra and then polynomial tools, you can find the roots of a polynomial. Degree is 2. -1 is your first coefficient, 2 is your second coefficient, 3 is your constant, and it gives you the x-intercepts of -1 and 3. All right, so now we know, okay, I'm finding the integral between -1 and 3 of the equation negative x squared plus 2x plus 3 dx, which means I first need to find that integral and then evaluate it between those two numbers. Go ahead and find that integral for me. That x squared becomes x cubed, and then I have to divide by 3, which means that that -1 becomes -1/3 x cubed, plus that x goes squared, divides out with that 2. So 2 divided by 2 ends up being just 1, so it's just x squared. Cool. And then that 3 just gets a little x added on. And we're evaluating it from -1 to 3. Go ahead and do the rest of this on your own. Remember that you first plug in 3, and then you plug in -1, and then you subtract. Yeah. Right. If doing it by hand stresses you out, no need to worry because you have a calculator. If you just plug in this entire thing into your calculator, you could just do it like that. Also, as long as you show me this before you show me the final answer, you would get points, right? So as long as you understand, you would get a method mark, or sorry, more like an accuracy mark for the correct integral, and then showing me that you're evaluating this. Maybe plugging these values in here, here, and here would be a method mark, but the rest of this, whether you do it by calculator or whether you do it by hand, is not that big of a deal. All right, that's it for today. We're just focusing on this, really honing in on this idea that integrals are the area underneath the